I had requests for Chapter 6 homework help. And you can request help like this anytime. I'm going to go ahead and send this out to the whole class. You can all benefit. So I think these are good questions. The first one was number 8. And she was able to get and yours might be a different number 8, okay? Just so you know, I'm calling it number 8 because it's her number 8. But just know that yours might not be number 8. Okay, so she was able to view the video and see that the metal went up to 86 degrees Celsius. You just begin the video and watch what the temperature goes up to. Okay. Go down. She was able to get the initial temperature of water right here is 22. And then she was able to watch the video and see what it went up to. Okay, and this is where she had trouble with. Now she knew how much the water temperature changed and how much the water weighed. And she knew how much the temperature of the metal changed because she put metal inside of the coffee cup calorimeter. And she knew the weight of the metal. But how do you find the specific heat of the metal? Well, you use this. Let me pull this up here. Okay. Remember that with coffee cup calorimeter, Q of the, hold on. Okay, so let me resume what I was saying. So we have Q of the water, remember, will equal to minus Q of the metal. So we have, remember, Q equals MC delta T. So we have all the information for the water. So we can put in, to find Q. Q equals M. M, they gave us, let's see, I wrote it down as 130 grams. C for water is 4.184, and delta T was 3. Just doing final minus initial, it was started at 22 and it went up to 25. So we put all that in. We go 130 times 4.184 times 3. And you're going to get Q of the water is 1.63 times 10 to the 3rd joules. Okay, so then we come back to this equation here. We know Q of the water, and Q of the water will equal to Q of the metal. So then we know Q of the metal then is, or negative 1.63 times 10 to the 3rd. M of the metal, you calculate it as 45. We don't know C, I'm put a question mark. And delta T is negative 64, final minus initial there. Okay, so if we plug that in, Q of the metal equals to negative 1.63 times 10 to the 3rd. M is 45. C, we don't know, so just put C. And then delta T is negative 64. So if we plug that in, you calculate this, doing a little algebra, you'll get C equals to 0.59, which is your final answer. So the big thing here is remembering this formula here, that if you can get Q of the water, that's going to be Q of the metal. Okay, that's the big formula for any of your calorimeter, not just coffee cup, but also bomb calorimeter. Okay, so let's look at another problem. Now this next one, let's see, it was number 12. You need to do in steps. Now this is a good one. This actually, this is a hard problem. It's not too hard if you break it down into the steps, but this is combining a few chapters together. Chapters 3, I believe it is, 5, and 6, okay? So the first thing we need to do is, well, it says an automobile airbag contains sodium azide that reacts to reduce nitrogen gas when inflating the bag. Sorry, I can't talk. Calculate the work of the following system. If 23.6 grams of sodium azide, so if all of this reacts completely at 1 atmosphere and 22 degrees Celsius to form your nitrogen gas, okay? So the first thing we're going to do is how many moles of nitrogen gas, okay? So we have our reaction. Here we go. So we have, oops, nope. 2NaN3 yields to 2Na plus 3N2. Okay, so we know that we have 23.6 grams of NaN3. Anytime we're going from a mole of one substance to a mole of another one, remember, at some point we're going to use a mole ratio. Okay, so the first thing we need to do is convert this to moles so we can do a mole ratio. If you get the periodic table and calculate the molecular weight of this, you're going to get 65 approximately. 65 grams of sodium azide is 1 mole. So that's the molecular weight, so 1 gram per mole. Now we can use the mole conversion because we have a mole that we can cancel out here. Remember, the mole conversion is going to use the stoichiometric numbers here, so it's be 2. We have 2 NaN3 moles for every 3 of nitrogen. 3 moles of nitrogen. Now, do you see here we have moles of nitrogen, so we just stop there. So we calculate it, we cancel out grams of NaN3, okay, and moles of NaN3 to leave you with moles of N2. Okay, so now if we multiply this out, so we do 23.6 times 3 divided by 65 times 2, you get 0.545 moles of N2. Okay, so this is, we'll say, step 1. Now step 2, view step 2. It says, now calculate the volume of N2 using the number of moles, pressure, and temperature. So when you see moles, pressure, and temperature, volume, right away you should think PV equals nRT. Okay, so let's come back here. PV equals nRT. So why did we do step 1? To find moles, which is N. So we know N is going to be 0.545 moles. Our pressure was given to us as 1 atmosphere. Our volume we're trying to find. Our temperature, they said assume it's at standard temperature, so that's 298. And R for these is 0.0821. Okay. Now all we do is we plug it into here and solve for volume. So pressure is 1, volume we don't know. N is 0.545, R 0.0821, I'm running out of room, and temperature 298. So multiply all these together and then divide by 1, and you'll get your volume. See what I get is 13.2 liters. Okay, and that's just doing some algebra, plugging those numbers into there. Now our last one, it says, now we need to find the actual work. Now remember, work equals to minus P delta V, okay? And this will end up coming out in liters, atmospheres, okay? Why? Because our pressure is in atmosphere, and our volume right here you see is in liters, okay? But it wants it in joules, so we'll look at that in a minute. Our pressure was given to us as 1, the negative right there, and our change in volume is what we just got, 13.2. So when we do this, we get 13.2 liters atmospheres. Well, we want joules, And so what we're going to do is multiply it by 101.3. 1 liter atmosphere equals to 101.3 joules. So then we're going to do 13.2 liter atmosphere. 1 liter atmosphere equals to 101.3 joules. Make that go away. So basically when you multiply 13.2 by 101.3, you're going to get negative 1,340 joules. And that's your final answer. Okay, so just do it step by step. Step 1, find your moles. Step 2, you do PV equals nRT. And step 3 is whenever you actually plug it in. So steps 1 and 2 are from previous chapters. That's why they give you the tutorial. And then step 3 is your actual chapter 6 part of the problem. Okay, so another question was 14. Okay, so there was 14 and 16. I'm going to show you how to do 14, and I'm going to kind of set up 16 so then you can figure out the rest. Okay, so let's look at 14. I'm going to write out the problem. We have, oops, did it again. Nope. So, okay. Let's use blue now. Okay, H2 plus F2 yields to 2HF, and the delta H for this was negative 546.6. And then we have H2 plus O2 to 2H2O. Delta H equals to negative 571.6. And our final equation we're trying to get is 2F2 plus 2H2O goes to 4HF plus O2. And we're trying to find the delta H of this problem. Well, sometimes delta H is hard to find. Maybe the reaction isn't stable or whatever. So we can actually find it by adding other equations together. So we know the delta H's of these equations right here, okay, these reactions. Now we're trying to see if we can basically manipulate them in a algebra kind of way to make this final reaction. Okay, so how do I go about it? I start with my final reaction. I find, you see, I want F2 to be a reactant, looking right here, F2, and I want a 2 in front of it. Okay, so I find F2 up here, which is right here. Now F2 is a reactant, but it doesn't have a 2 in front of it. So how can I put a 2 in front of it? Multiply everything by 2. Now whenever you do something, you can't just put a 2 in front of F2 because you want it. You have to multiply the whole entire reaction, including the delta H. So let's multiply this by 2 also. Okay, now water, I want as a reactant, and I want a 2 in front of it. So I look right here, H2 has a 2 in front of it, but it's a product. So what do? I want to flip it. Flip. I want it to be on the other side. So when I flip a whole reaction, I have to flip the sign of this delta H. So instead of being a negative, it'll now be a positive. Now let's check the rest. HF, I want a 4 in front of it and as a product. So I have it as a product. Now right now it shows a 2, but you see here I'm already multiplying it by 2, so that'll become a 4, so that's good. And O2, here I want as a product. It shows as a reactant, but you see that we've already flipped the reaction, so it'll actually be on this side. Okay, so everything's perfect. Now all I need to do is add these together. So I'm going to have negative 546.6, and actually let's put this negative right here, times 2 plus 571.6. I add those together and I'll get this delta H here. Okay, so I'll get negative 521.6 kilojoules. Okay, now let's look at the other one. Now I want you to practice this one, but let me get it started. Here's 16. So this one's longer, it has more steps to it, but it doesn't matter. All right, we just look at our final reaction and we make sure everything up here corresponds to our final directions if you want, okay? So we want M solid to be a reactant, looking right here, and have a 2 in front of it. So find it up here. So I find it up here. M has a 2 in front of it and it's a reactant. So it's perfect. I don't need to manipulate this reaction at all. Now let's look at Cl2 gas. And I find it right here, Cl2 gas. It is a reactant, which is what I want, but I want a 3 in front of it. Okay? So what do I need to do? I need to multiply this whole entire reaction, including delta H, by 3. Okay, now let's go to the next one. 2 MCl3 solid. Now notice there's an MCl3 aqueous and an MCl3 solid, so be careful of that. I'm looking right here. I want it as a product, you see, but it's a reactant. So what do? I have to flip this whole reaction, which will change the sign of this delta H. And I want a 2 in front of it. So not only do I need to flip it, I need to multiply everything by 2. Okay? So including delta H. So when I do that, let's see, what did I do? The reactions 1 and 2 stayed the same. Those don't change. I didn't need to do anything with them. Step 3, I needed to multiply everything by 3. So this will be a negative 1,845 multiplied by 3. And then this one here flips, so it would be a positive. And then I'm also going to multiply it by 2. So once I add all of those together, including my manipulations, I will get my final delta H. So make sure you understand and know how to do that, okay? Now, if you have any further questions, please let me know. I can work out more questions or even give you some more practice questions. Anyway, good luck with everything, and I hope this helps.